we're going to plot circles. What I'm doing here is putting right under the equation of the circle that we're going to graph the standard format for the equation of a circle with the identifying information. So you know when you see y equals mx plus b, there are places where numbers go and you know how to interpret those numbers. The number that's in the spot where the m belongs is the slope, and you know how to interpret that. And you know how to interpret the number that plays the role of plus b as the y-intercept. This is the standard format for the equation of a circle, and the numbers that could go there, there, and there each have a role to play. The two numbers that are attached to the x and the y underneath the squared terms, the names for those values are defaulted to h and k. I don't know why. But those give us the location of the center of the circle, and r from the right-hand side gives us the radius. So r squared is the template where r is the radius. So whatever number is sitting there, that helps you learn what the radius of the circle is. Our particular line, circle, it's given as x minus 1 squared plus y squared. If we match this part of our equation to this standard template, we see that h is 1. If we match this standard template to that, we see that there isn't a k. Now, that doesn't mean that the problem's broken, it just means that k is 0. Which means that the center of this circle is at the point 1, 0. And then, let's match this to that. The standard template says the number sitting here is the square of your radius, so we know that r squared is 9, so we know that the radius of our circle is 3. And so a picture of our circle, I'm going to draw it very tiny here because I don't want to use up too much space. I have a center of 1, 0, and then I have a radius of 3, so 1, 2, 3, 1, 2, 3. How about like that? Awful circle, but you get the idea. Down here, we don't have things that are already prepared as perfect squares. That's sad. But what's good is that we have a technique that allows us to introduce perfect squares where they don't exist already. The first thing we might want to do cosmetically, just looking at the way this lays out and looking at that, this particular standard template wants us to have a constant over on the right-hand side that isn't 0 because we would like to have a radius not be 0. So how about we move this 2 over there? So I'm going to do a couple of things here. I'm going to rewrite the bulk of this quadratic expression with some cleverly placed spaces that we're going to fill in, and I'm going to move this -2 over there, over to the right. So just add 2 to both sides. All right, now what am I doing with the extra space? Well, a couple of topics ago, we talked about something called completing the square, and we are going to do that. If you remember, completing a square is a way to generate perfect squares where one doesn't exist, and it's magic. As a reminder, what we do is we introduce a constant here so that the x squared, this -8x, and whatever constant ends up there ends up being a perfect square. And we can design that constant, and it's actually pretty easy. All we do is go to the constant that's on the x, which here is -8. We divide it by 2, which produces a -4. We square it, which gives us 16, and that number gets plopped right there. Now over here, we're going to do the same thing. We're going to complete the square on the y term. So our y squared is happy, our 4y is happy, we just need the constant. So we're going to back up to the y term, grab this number, and how about we do it all at once? I'm going to take this 4 and divide it by 2, which gives me 2. I'm going to square that, which will give me a 4 again, and I'm going to plop that right there. Now you have to be careful. We are in charge of this expression. We are allowed to add in constants if we want to, because we're in charge. but we're not so far in charge that we can do it without rules. Since we added a 16 and we added a 4 to the left-hand side of this equation, we also must add a 16 and a 4 to the right side of the equation. Now everything's happy. And the reason we do that is that this grouping around the x's, that is a perfect square. And it happens to be x minus 4 squared. Again, that number is the key to everything. It gives us that term, and it also gives us the constant in the binomial that is the perfect square. And then here, the three terms about the y's, y squared plus 4y plus 4, that factors to y plus 2 squared. And then over here, we have 22. And then again, it's written up at the top, but I'll write it below. The standard format for the equation of a circle looks like this. So we can just match them up. H is 4. K, well, the template wants y minus k. We have y plus 2, which means that our k is negative 2. And here, r squared wants to be 22, so r itself is the square root of 22. And so the center of this circle is the point 4, negative 2. The radius is the square root of 22. That number is bigger than 4, but less than 5. There it is. Well, I guess we can try to draw this. Got a little bit of space. It's not going to be a good drawing. 1, 2, 3, 4. 1, 2. There's the center at 4, negative 2. And then we need a radius that's bigger than 4, but less than 5. Good grief. So how about there? And 1, 2, 1, 2. Probably about up to there. So let's... Hey, that's looking pretty good. Whoa, look at that. That's a pretty nice circle.